So number 8, we also want to find x-intercepts, which means we're going to have to factor this first. We talked in the video about number 6 how we're always going to check for a GCF first. I do not have a GCF here because there's no number that goes into 3 and 10, for example. And so then we look at the number of terms we have. With 2 terms, we would try to be doing either a cube or a square, we're looking for perfect cubes or perfect squares. With 3 terms, we would do trial and error, which is where we just had the 2 sets of parentheses and we were guessing the numbers and checking. And then if we have 4 terms, we're going to be doing grouping. So we can see we have 4 terms here, so we're going to be doing grouping. So we're going to group these 2 together, and we're going to group these 2 together, although there are other ways you could group them. And we're going to pull out a GCF from the first group. So it looks like I could pull out a total of 3x squared. That's the biggest thing I can pull out. That would leave 1x here and just a 5 here. I'm going to bring down this plus sign, and then I'm going to factor out the GCF right here, which looks like it'll be 10, which leaves me here with x plus 5. So that's the first step of factoring by grouping, is little GCFs, small GCFs. Small GCFs. The next step is we're going to take a large GCF. Between this term and this term, there is something that they have in common. They have in common x plus 5. So I can pull out, as a GCF, the x plus 5. And what I'm left with then, to get this term, I did x plus 5 times 3x squared. So right here I need to put 3x squared. That's how I got this term. I did x plus 5 times 3x squared. To get this term, I did x plus 5 times 10. You might have to think through that a couple times before you see it. But I can pull this x plus 5 out, and all I'm left with is 3x plus 2. And I can pull this x plus 5 out, and all I'm left with is 10. So if I were to distribute this whole thing, you could try to think of it as just one object, times this, and then times this. It would, in fact, give me what I had up here. So this is the factorization. And so to find my solutions, right, I'm going to set it equal to 0. So I'm going to set x plus 5 equal to 0. So one of my solutions is x equals negative 5. Which I guess I should write as an ordered pair, since it asks for an x-intercept. And then 3x squared plus 10. You can solve that. It won't factor anymore. You could put it in the quadratic formula to see if you can solve it. Or if you think about this graph, well, let's just put it in the quadratic formula. So if we have 3x squared plus 10. So my A term is 3. My B term is missing. I don't have an X term here. So B is 0 and C is 10. And if you start to put this in the quadratic formula, you have negative 0 plus or minus 0 squared minus 4AC over 2A. So we have 0, and then 4 times 3 is 12, and then 12 times 10 is 120. So this is minus 120. And you can already see what's going to happen here. This is going to be negative, so this is going to be imaginary. Keep in mind that the question asked for x-intercepts. So if this part of my function is going to give me imaginary solutions, will I get x-intercepts? And the answer is no. So I will have 2 imaginary solutions here, but I don't need to find them in this problem because the directions didn't say to solve, it said to find the x-intercepts. So there are no x-intercepts from here. There's only one x-intercept on this graph.